Welcome back. In the last episode, we talked a bit about arrays. Now, we're going to see how to get data into arrays quickly and easily. So we've rewritten our little test bed program here, and we're going to introduce some new concepts. First, we're going to learn how to use data statements. By convention, you put your data at the back of your program, sort of out of the way. Not really necessary, but works better. Now, I've got two kinds of data here. One is called my numeric data, and those are numbers, right? 10, 100, 1,000, 10,000. And you can see they are separated by commas. Then I've got string data. This is an example of how to put string data into an array. I could also separate those by commas. There's no problem with that, but this is a little bit easier for you to read. So, as you can see, string data is not restricted to a single word. And in fact, I've put a little space at the end of the first four, because we're going to put them together into a sentence. Right, so you have data and then the data follows. So what is data for? It is for information that's not going to change very often. It is, where you can put the labels for menus. It's where you can put your help messages, all that sort of thing. And since it doesn't change very often, it basically is not going to change until the next release of your application. You can just put them here, and when the time is right, you can change it. Okay, so here we have something called label. Now, unlike some older basic dialects, Yab does not use line numbers. It can, but then they're just special forms of labels. You don't have to say label 10, label 20. You can just say 10, 20, 30 if you want to. Really, unless you are converting an ancient GW basic program, just avoid line numbers. They're not worth it. Okay, so, but what is this for? Well, they are for the restore command. Restore says start reading the data at this label. Right, so restore my string data means start reading data here. If you don't use restore, it'll simply read the first thing it sees, the first data statement it can find. That's what I'm doing here. Read headers, right? So this means take the first data statement in this entire program, which is here at the bottom, and print it, and then print an open line. Now I'm saying, okay, make two dimensions, a string dimension and a numeric array, two arrays, a string array and a numeric array. Then restore my string data. Now just to make a point, I've put my string data at the very bottom after my numeric data, just to show you how this works. Right, and then we have our little loop. Which said, read the next piece of data and put it into this array and print it. Then we do the same with numeric data. Right? So what this means is you are now over here, but jump over here to this label and read 4 pieces of numeric data. Now sometimes you don't have a fixed number, and then you need a different kind of loop. Right? If you're writing a help file, that can change a bit more often. You don't want to sit there counting the lines. So what then I do at the end is I put in a marker, something like end of data. And then I say, keep reading this until you've come across something called end of data. Okay, so shall we see how this works? Right, so first I read this bit here at the bottom and I print it. There it is. Then I print another line. And then I read my string data, print it out. Oops, sorry about that. And then I read my numeric data and print that out. So one thing you will see is that when reading this data, somehow a line feed got into this. There are ways of filtering those out. I haven't bothered because it's a bit more advanced, right? But that is why I'm not getting a single sentence, even though I put a semicolon after the print. In fact, if I take this out and run the program again, then you clearly see that there's an extra line feed there. See? So don't worry about this now. There is a trick to remove extra line feeds. I'll make an episode about that. It's a little bit of a routine that you just put in there. Okay, I'm going to go away now, and when I come back I will have rewritten this program to read data into an array from a file, which is a different procedure. And we're back. So this time, instead of reading variables into my array from a data statement block, I've decided to have a separate file with exactly the same information, but in a file. And you can see how I've even put the little spaces at the end. So there must therefore be a way to read this file into my program. And you can see the lines in red here is what has changed. So first you open the file. Now I will have at least one episode on open. There are several versions of it, several ways to write it. This is just the way I'm most comfortable with. right? So you open it. What do we open it for? We want to read it. Now, you can't read and write to a file at the same time. That would be bad. Right? Well, you can open it as binary, but let's just stick with sequential reading for now. Right? So you read the file. In other words, you get the data out. And as what? As channel 1. So this little pound sign, hashtag, whatever you want to call it, indicates a channel. It's actually optional, but it's kept on for compatibility reasons, and I just learned how to open files like this many years ago, and I still use it. Right, so now instead of saying read a line of data, which, by the way, is still in there, I haven't taken them away, but they're now just not doing anything. It says line input channel 1 into the appropriate member of the array, right? And then print that, right? And then when that is all done and you've got all the data you need, then you close the file. And it's very important, when you open the file, you have to close it. Don't just leave it open because you think you might need it again later. Close the thing. Because sooner or later you're going to run into a problem and where the program says, can't open this file, the file is already open. And now you have to go look through hundreds of lines of codes to find out where you didn't close the thing. So how many of these channels do you have to work with? I'm not entirely sure, but I think it's either 16 or 32. Probably 16. I don't remember it being a very high number. Yeah, but maybe somebody will correct me on that. But you are very rarely going to need hundreds of files to be open at the same time. If you need that, if you need hundreds of open files, then there's something very wrong with your program design. So open them, take what you need, close them. Right, so let's run this baby. And as you can see, it looks exactly like the other one. So whether you keep your data in data statements or whether you keep it in a file, we can end up with the same result. Now, when do you use one or the other? Well, I personally am very fond of data statements. I think that I'm the only one who still uses them. But I like a program that is one file, right? And what if your users move this desktop my data somewhere else? Now the program can't find it. Whereas your data travels along with the program, it'll always be there. So the flip side of that is that if you want to update it, you now have to compile a whole new version of the program. Whereas if you want to update this setup where you use external files, you can just tell the user, download the new text file and put it there, and well, you'd automate that actually, but that's a more an easier way to update your program, or at least the data that it uses. So you decide. So this is just an initial look at using external data files. We're going to have many lessons on this because it can get quite intricate. Okay, thanks for watching.